Hi everyone. I'm pleased to introduce Akshay, a dynamic and skilled data scientist with 4 years of experience in the field. Currently serving as an associate consultant in data science at Infosys BPM AI Center of Excellence, specializing in natural language processing. Akshay has developed a niche in creating custom document intelligence solutions. Please join me in welcoming Akshay Dev, a data scientist par excellence, as he shared his insights and experience in the world of data science with us today. Welcome, Akshay.
Thank you, Sonam. So, my name is Akshay, and I primarily work in building custom NLP solutions. So, I assume everyone here is from a technical background, right? So, how many of you heard of NLP? Could you just put your hands up? That's a good number. So, NLP is basically natural language processing. How do you get computers to understand text? How do you get computers to understand our language? That's the main goal of NLP. And today I want to talk about document intelligence in particular. Document intelligence is one of the most applied or one of the most widely used applications of NLP in industry. So no matter what company you are, after a certain size, every company needs document intelligence. So you cannot escape paperwork, right? You cannot escape filling in forms and processing forms, no matter what sort of business you are in. So document intelligence basically deals with how do you make that process efficient? How do you automate that process? So I want to share some insights, share some learnings that I've learned over the last 4 years in building custom NLP solutions. Hello. Is the mic working? So let's start with what is document intelligence. So document intelligence basically at its heart is taking unstructured data. So you have unstructured data in PDF documents or Word documents or PPTs or Excel sheets, can be in any format. And then you convert them into a structured or a semi-structured form, and then you try to extract insights out of it. So till now, so far, people have been using classical machine learning and classical deep learning techniques to implement document intelligence systems. But what I want to talk about today is how can we use large language models. So ever since large language models broke out into the scene around last year, and I think ChatGPT was released around last year November, right? So there's been a huge revolution or a huge things that suddenly became possible in document intelligence. So before LLMs, there were a lot of things that you could not do or was very, very difficult to do. But with LLMs, it's all possible now. So I want to talk about the market, document intelligence market's current state. So in 2021, just the document intelligence solutions market alone was valued around at $1.1 billion, and this does not encompass the whole of NLP solutions, just document intelligence, and it's expected to grow at 30.1% CAGR. And you're seeing more and more companies adopt document intelligence solutions, especially in developing countries. So the thing about document intelligence solutions is that you don't need much technical expertise, or you don't need to be at the top 1% of technical resources to have a document intelligence solution. So it's relatively easier to implement and it's cheaper to use also. So I want to touch upon what document intelligence solutions were like before LLMs. Hello. So before LLMs, you had to custom create every component of your solution. And the models we had, the deep learning models we had, how they understood text was very limited. So you could not pass in any text or complex text and get an accurate response. But with the advantage of LLMs is that it can almost understand any type of human text, right? You guys all must have used ChatGPT, and it is pretty good at understanding our intent, right? And pretty good at generating a suitable response. So, for LLMs, you had to have a fine-tuned model for everything, and that put constraints on your flexibility, that put constraints on your adaptability. But with LLMs, all these limitations can be overcome. Obviously, not completely overcome, but overcome to a good degree. So, before I talk about what is possible with LLMs, I want to touch upon what is not possible. Because there's a lot of misconception about LLMs floating around. People think that it's a magic bullet for every type of solution, for every solution out there. But that's not the case. Even LLMs, even the most impressive LLMs like GPT-4 and all have some limitations. So one of the major limitations that people immediately recognize is that LLMs are pretty bad at reasoning and planning. So compared to a human, an average human, LLMs are extremely bad at reasoning and planning. So you cannot, give it a reasoning task or you cannot tell it to plan something. Things are probably gonna go wrong. And the second biggest problem we are facing right now is how to ascertain a fact or a statement generated by LLM, how to ascertain if it is factual or not. So if an LLM generates something or makes a statement, how do you know it is true? And the problem is LLMs have been trained to follow instructions and have been trained to generate responses that we humans find pleasing. They don't have any idea or they don't have a concept of truth or factuality. So this makes things difficult whenever you have an application that needs some fact checking, that needs some objectivity. LLMs are risky to use. So there are existing workarounds. We'll get to that later. But again, the problem is not completely solved. The first two problems I just talked about, they're still huge. People are still working on them. Maybe in the next 5 to 10 years, we might see some impressive solutions. So now, what can you do with LLMs? How does using an LLM change, or what do LLMs bring to the table when it comes to building a document intelligence solution? The first thing is LLMs are really, really good at understanding human language. So especially popular languages like English, you ask it something, it will try its best to understand and give you a response. So for a lot of document intelligence tasks, this understanding is crucial. You need to understand what sort of documents you're dealing with, what sort of domain you're dealing with, and LLMs make this possible. So you don't need to fine tune a model, you don't need to go out of your way to collect a specific data set, spend a lot of money on fine tuning the model. All that is not required anymore. You can just use an LLM directly and get their understanding abilities. Some standard NLP tasks like summarization. I hope you guys all know what summarization is, right? You get a passage and you have to summarize it. Now, summarization is a very subjective. People might find different summaries pleasing. Not everyone can agree on what could be the best summary for a specific paragraph. And the problem with existing deep learning models was the datasets were scarce. So you just had 2 or 3 publicly available summarization datasets. And whatever models you could build with publicly available data, that was very limited. So even though there were deep learning models for summarization, most of them weren't good. You could not use them in production. And similarly with question answering. So question answering is basically you have a document, you ask it a question, it should generate the right answer based on the document. Same story there, you had some models, you had some publicly available data sets, but very, very limited. You could not use them in production, you could not use them in real life basically. So only a very, very few companies with the resources to get enough high quality data and get enough training compute could build an impressive deep learning summarization or question answering model. But again, LLMs make that very easy. So you can do summarization pretty much perfectly. Like I would say for short to medium range documents, summarization is effectively a solved problem. Same thing with question answering. So that's the whole beauty of LLM. Whenever your input is a string and whenever your output is also a string, you can use an LLM to define a task and let it actually do the task. So it's very versatile. You can use it for a lot of applications. So how many of you have heard of RAG or retrieval augmented generation? Have you guys used it? So RAG is basically using a retrieval model in conjunction with an LLM. So what is a retrieval model? So retrieval model is basically a model that's used to carry out search. So you have a bunch of documents, you want to search against this bunch of documents, you enter a query, and the query obviously gets converted to a vector. You have all your documents in a vector form, and then you use a metric like cosine similarity or Euclidean distance to find the most similar documents to your query and pull those results out. So one of the major limitations of LLM right now is their context window. Most LLMs only have a context window of about 4096 tokens now. Obviously, there are newer models now which incorporate 128,000 tokens and all, but it's still pretty limited. When in real life you'll have a document collection of 1 lakh or 2 lakh or maybe even more than 10 lakhs. So you can't rely on an LLM to process your documents. So the solution to that is currently what most people use is retrieval augmented generation. You have a retrieval model, user types in something, it gets converted to a vector, your document collection is also in vector form, you do some sort of similarity matching, pull up those results, just pass those results into the LLM and tell it to generate an answer. So this is sort of like a workaround. We are not solving the problem, we are offloading a major part of the problem to this retrieval model, right? But for real world use cases, it still gives pretty good results. So I want to talk a bit more about what goes into building an RAG pipeline or an RAG system. And the first part is chunking. So how many of you guys here have worked with embeddings, creating vector embeddings out of text? Which model do you use for embedding? Which one do you remember? OpenAI embeddings itself? Okay. I mean the paid one, right? How was it? I mean, how was the performance and all that? Pretty good. So, like you guys said, you can use open source models for embedding, or you have paid ones like OpenAI's. And before you can use an embedding model, you need to chunk your documents. So you need to split your documents into chunks and only then embed. And again, this is because embedding models also have a context window limitation. You can't just pass in your whole document set to your embedding model. So usually open source embedding models, they have around a limit of 768 tokens. Some of the older ones have around 300 or 512. The newer ones like OpenAI's have around 1536 if I remember correctly. But again, you need to chunk. So this chunking process actually determines how your embedding model's performance. It also determines your final LLM outputs performance. So it's a pretty crucial part of the RAG pipeline. And depending on your use case, depending on what trade-offs you're willing to make, you can choose different types of chunks. So sometimes you might want to have longer chunks. So if you have longer chunks, you have longer context to maintain. Sometimes you might want to have smaller chunks because the context is short. So depending on what you need, you can customize your chunking algorithm. At the end of the day, it's just splitting text. We split text cleverly, that suits our application's needs. And then we get to the actual embedding model. So once you have your chunks, you're ready to create embeddings out of them. So you pass them to an embedding model, and then a collection of chunks goes in, and a collection of embeddings comes out. So for each chunk, you get a corresponding embedding, right? And the cool thing about this is, when a user types in a query, we use the same embedding model we use to create the chunks. So the user's query and your document chunks embeddings, they're basically in the same vector space. So since they are in the same vector space, that means we can use similarity metrics like cosine similarity or Euclidean distance or Jaccard similarity, right? How many of you guys here have used cosine similarity? And I'm going to talk about vector DBs also. So vector DBs or vector databases have been there for a while, but they have been gaining in popularity in the last 4 to 5 years, especially in the last year after LLMs came out. So vector DBs are DBs, but they're optimized for storing high-dimensional vectors. So the embedding models we talked about earlier, they all produce some vector, right? And I'm pretty sure all of you guys here know what a vector is. And when you have a high-dimensional vector, storage gets pretty expensive, right? Not only do you need a lot of storage, the latency should be low also. So things get expensive pretty fast in production. So the idea behind vector DBs is it's optimized to store these high-dimensional vectors that these embedding models produce, right? So they have these vector DBs have already implemented some search algorithms. So whenever you need to compare embeddings or search through embeddings, it's super fast, it's super optimized. So all that is taken care of for you. So as a developer, you don't need to worry about optimizing for latency or anything, right? And they're also pretty scalable. So vector DBs also, you have open source variants and you have paid closed source cloud variants or other third-party providers. And depending on your usage, they charge you. So technically, we don't need to do much. We just need to dump our embeddings into a vector DB. We don't need to worry about actually how this DB is implemented. And so it makes things pretty easier. Finally, I want to talk about an under-mentioned or under-talked about type of embeddings called as instruction embeddings. So this is a relatively new type of embeddings. It came out last year. And the idea behind it is just like you can prompt an LLM, right? Everyone's used to prompting an LLM. So you can prompt an embedding model too. So the way it works is you describe a task and you tell the embedding model, hey, create embeddings customized for this task, and it will create embeddings customized for that task. So a normal embedding model, your standard embedding model, it just generates embeddings. You cannot customize it for a particular task, right? But with instruction embeddings, it's possible. You can customize your embeddings for whatever task you need. Coming to that. This. Yeah. So basically, let's say you have 3 tasks. One is find a duplicate question, one is retrieve some documents from Wikipedia, and one is classify the question's topic. 3 different tasks, same input, right? Giving the input saying 3 different tasks. I pass it through my instructor embedding model. I get 3 different embeddings for each task. So basically, you change the task, which is the prompt here, which acts like the prompt here, and you get a different set of embeddings. But the input remains the same. Is it clear? Yeah. The input is this. Let's say this question, who sings the love story, right? I'm saying the first task is find duplicate questions related to it. Retrieve some documents from Wikipedia. Classify the questions topic also. You have a classification task, you have a retrieval task, you have a somewhat like search task again. And I get 3 different embeddings for the same input, for the same sentence. So depending on the task, the embedding value changes. The vector's value changes. Is it clear? So I think, if I explain this a bit, it'll be more clear. I think you're confused on how you can create 3 different types, right? So basically what they did is they took an embedding model, they created data sets across a diverse range of tasks. So text similarity, question answering, fact checking, sentiment analysis. For standard NLP tasks, they created diverse data sets within a data set. So they put together 330 data sets for different tasks and created one big data set out of it. Then they train this instructor model on it, right? And then they evaluate it. So what they did is, for each task, they made a prompt. Hey, this is the task, this is the data set you're gonna get, and create some embeddings. And they trained it end to end. So essentially, depending on the task you specify, the embeddings that gets generated changes. So even if the input sentence is same, the embeddings, if your task is different, if your prompt in this case is different, you end up with a different embedding vector. So the cool thing here is you can customize your embeddings without training. Because in a normal embedding model, you have to train your embeddings, right? You have to fine tune if it didn't work for whatever domain you are trying to use it in. So you have no choice but to fine tune. But here you have this option of changing the embeddings by specifying a task. Is it clear? Instruction embeddings? No, it's not computationally expensive. It's basically, zero shot, few shot learning and all that, right? So it basically does zero shot learning. So that the task prompt, right? That is what does the zero shot learning. So depending on that, it will create a different embedding. But obviously it's not as good as properly fine-tuned embeddings. That will still be better. But we always don't have data, right? Or we always don't have time to. So cases like that, this instruction embedding model works really, really well. So, I want to talk about augmenting LLMs with standard NLP techniques or standard data science techniques. So LLMs are powerful, you can do a lot with them, but we can still use established techniques or established practices to make them even better or make them even more powerful. So one of the use cases I was working on about a few months ago was finding topics within a company's ticket collection. So they had a lot of Jira tickets, right? And the topic could be anything across different departments. So the data set was pretty huge, around 200,000 to 300,000. And they wanted to find topics automatically. And for each topic, they wanted to generate a summary. Now the issue is, again, a language model's context window is limited. You cannot directly pass this in, obviously. It will fail. So what I did is, I first ran it through a topic modeling layer. So my topic modeling layer was basically just creating embeddings, semantic embeddings, and then running a semantic clustering algorithm on top of it. So some of you must have used a clustering algorithm, right? At some point of time, k-means or HDB scan or whatever. So in my case, I used HDB scan, and I got specific clusters. So each cluster, I'll have similar topics, right? But the data, or even within a cluster, the sentences again were too long. So I clustered it at one more level, and then you ended up with clusters within clusters. And then finally, I got it down to a point where I could pass it into my LLM and generate a summary. So I can go to each cluster. Within the cluster, I can generate 10 more clusters, and for each cluster, I can get a summary. So this way, you can evade the limitation, right? So similarly, one other application is in recommendation systems. So in recommendation systems, you have basically two methods: collaborative filtering and content-based filtering. So content-based filtering is basically you have some user query, you're filtering the content against it using some model, and then getting some results. It's similar to search, but with small subtle differences. So in content-based filtering, again, you can't pass in the whole thing to your LLM. But LLMs are pretty good at understanding relevant content and generating recommendations. So if you want to make a movie recommendation system, you can feed it synopsis of some action movies and tell it, hey, search the web and find some action movies similar to this, and it will give you good results, right? So again, we can integrate other tools. So in this case, it's web search, and LLMs can give you a much higher quality output. So if you just use LLMs, it will be pretty limited. So the idea is, hey, there are these existing techniques. Let's use them together with LLMs, to get a better output. And also, LLMs are, you get charged based on how many tokens you use in LLMs. So the more tokens you use, the more you get charged. So most companies or most projects, they'll have a hard limit on how many tokens you can use, right? You can't use as much as you want. It has to be within budget. So combining LLMs with standard techniques could help reduce this token usage also. So the entire load doesn't need to go to the LLM. And one more, under-mentioned application of LLMs is generating labels, so generating gold standard labels. So for a lot of text-based ML tasks, you need labels or you need supervised learning, right? And you don't have data for it. Sometimes the client also, they won't have data for it. So what do? And one cool application of LLMs is you can define a small data set, let's say 50 to 100 rows. You can tell the LLM to use that as a reference, and then you can tell it to label, unlabeled data. So if you have a lot of unlabeled data, you just need to give the LLM some guidelines and it will label the data for you. And the labeling will be pretty good. And once you have labeled data, you can apply standard models like XGBoost or random forest classification, whatever, and then create a text classification model. So this again is pretty useful, right? So we just use the LLMs to label. We then train a model out of it, and that model probably will scikit-learn or something, which is open source and free for everyone to use, right? So not only would we get good accuracy, we also reduce our cost, reduce our latency and all that. So for simple NLP tasks like classification, aspect-based animal analysis, NER, you can use GPT 3.5. For more complex tasks, you can use GPT 4. Now I want to talk about having this mental model of LLMs as query engines for the web. So a lot of people have have a lot of misconceptions about LLMs, how they work and all that. And I want to demystify some of it. So basically, when you're asking ChatGPT is, you can think of ChatGPT as an advanced query tool that searches through its entire training data set. So ChatGPT was trained on the entire worldwide web text corpus up to 2021, right, September. So you're searching through this huge, gigantic text corpus, right? And that's what you're doing. It's not generating, it's not thinking like a human. It does not have any agency. It does not respond to you in particular. It's just taking your prompt and searching through this huge embedding space and trying to get some relevant answer to you, right? And this is why if you make a small change in your prompt, you get a very, very different answer. So if anyone who has done prompting here must have noticed that, right? You change the prompt and your response changes a lot. And open source LLMs are also catching up. So Hugging Face Hub, a lot of you guys must have used here. It has become sort of the de facto repository for models. So one model in particular I want to talk about is Mistral 7B. Have you guys heard of it? Anyone? Did you use it? Llama 2. How does it compare to GPT 3.5? After quantization, what was the size? The size of the model after quantization, what was it? 8 GB. And how many parameter reduction? 7? 7 billion parameters. The Llama 7B one. Okay. And how did it compare to 3.5 after quantization? What about the answer quality itself? Like, was it fine? Okay. Okay. Okay, nice. So, Mistral again, it's getting a lot of recognition. Mistral 7B. People are saying it's almost as good as GPT-4 in certain tasks. And someone, I think a week ago, in another research organization trained on top of Mistral, and they made it even better. And today morning, I think before coming here, I saw Intel released a model that was trained on top of Mistral 7B, which was again getting good impressions from people. So open source LLMs are catching up. We still have maybe a couple of years, or at the most 4 or 5 more years before they fully catch up to closed source models. But yeah, you can use them for simpler, less complex NLP tasks. And then of course they're more cheaper to use, they're more transparent, they're more flexible. You can change the architecture, you can change the hyperparameters, right? With OpenAI's models, you can't do anything. It's completely closed off. Yeah, one more thing is multimodality. How many of you have heard of multimodal models? Right? So, multimodal models can deal with multiple modalities: image, text, audio. The most common type of multimodal models are image text models, where it can process both images and text. Right? So GPT-4's Vision came out recently, where it can understand images for you, and it is surprisingly good. Right? Whatever image you throw at it, it does a pretty decent job of understanding it. You have open source models also, like Blip, Lava, and all that. But they're not there, they're not up to GPT-4's accuracy yet, but they're reaching there. Now, the thing about multimodality is when you process documents, a lot of times you find images embedded, right? And you can't process images with an LLM. So if you have a multimodal model that also understands images, that's a huge advantage. That solves a huge headache for you. Because a lot of times PDFs or Word documents or PPTs will have images, and those images will be essential to understanding the context. So multimodal models could offer up a solution to this issue. No, OCR is just converting the text part, right? You still don't understand the image, right? Because if I have an image with some objects in it, I can't use OCR, right? That's it. Thank you.